So before we wrap up the discussion of Ruby in this module, I want to discuss two more concepts, which I probably would not have discussed otherwise, but you're probably going to see it out there in Ruby code out there. So I want to talk about it. So number one is the symbol to proc trick. So symbols have a to proc method which converts a symbol to a proc or a lambda. Now, I haven't really discussed procs or lambdas, but they just stay with me on this one. This could result in extremely concise code for methods like enumerable map, but it only works if a method does not take a parameter. So I think it will become obvious with an example. So let's say you have a struct or a class person, name, age. Let's say the only method you're doing over here is old enough. If age is more than 21, you're old enough, that's a method in the person class. You create a bunch of people, Max, Joe, and Susie, and you have an array of those people. Okay. So you could do a method called select, which basically says, is a person old enough, right? So select all the people who are old enough, and then get me those people's names, right? That's what you're trying to do. Max, Smith, and Susie are the people who are old enough. They are 21 or older. Now, the select method, in this case, takes a block, which is takes a person, and then it calls the old enough method on the person to determine the selection. Map does something similar. It also calls the person, and then it calls the name method on the person, right? So you see this pattern over here of taking the parameter and then calling the method, in this case old enough, in this case name, for that thing being passed into either the select or the map. Now, you could do something very similar, actually identical, with just by saying ampersand, colon, and then method name. Ampersand, colon, method name. So in this case, it's old enough. In this case, it's name, and it looks much more concise. And the way this works is that you're taking the symbol, which is the old enough, in this case, or name, so basically a method name, and you're converting that into something called a proc, which is really what the select of a map expect. It's a block with a condition, what you're trying to do over here. So in case of select, it's the proc is old enough, symbol converted to a proc. And in case of map, it's name symbol converted to a proc. Now, as I mentioned in the slide before, this only works if the old enough, in this case, or name, doesn't have another parameter on it that it takes. So let's say if old enough would be old enough and some kind of a parameter, you wouldn't be able to use this pattern. This whole idea of converting the symbol to proc, which happens automatically, only works if there's no parameter passed into the method. So you'll probably see code like this in other places. Don't get nervous about what this is doing. All this is doing is just really a short form for doing this, where you say person, right? So you cut the person out of here, and then you just say old enough, and it works the same way. The other topic I want to talk about is equality in Ruby. Ruby seems to have a whole bunch of methods for comparing things. Now, the one that's used most often is this one, the double equals, which is really the business equality regardless of the class type. It compares it. That's the equals. Now, you also have the equal question mark, which you could use, which is same exact object. It's kind of a rather extreme, right? So equal is same exact object. Double equals is business equality regardless of class type. And then you have a triple equals, which is similar to the double equals, but it lets you compare things like regular expressions and ranges in case statements. And then you have the EQL equal, which is same as double equal, but it makes sure that the class type is the same as well. So let's see an example. So let's say you have three variables, A, B, and C. They're all 1, but B is actually a float 1 as opposed to an integer 1. So A and B are going to be true even though B is 1.0 and A is just 1. That's just how it is. It's business equality. It's 1, right? At the end of the day. So that's fine. Now, equal, EQL, is going to be false because EQL makes sure that the type is the same, and obviously integer and float is not the same type. Now, EQLC is going to be equal because integer 1 and integer 1 are going to be the same. Now, equal as an EQUAL, even if you do 1 and 1, it's going to be false because these are different objects. Right? So even though the value is the same, they're both 1, but they're going to be different objects. This one is a different instance than this one. And what I mentioned about triple equals, the case statements implicitly use this triple equals, which is this interesting case of an equal. It's not really equal, it's like it's doing some kind of a function of it. So for example, in the case of a range, is this part of a range? Is it equal to the range? It's not really equal, but it's this triple equals. Or for example, regular expressions, right? When you could do 1, it's a word character repeated 3 times, then puts bingo. 1 is not really equal to this regular expression, but it's this interesting triple equals, which basically says, you know what I mean? Basically compare a regular expression with a string, and if it's calling the match match method, which of a regular expression, and if a regular expression matches with a one string, then print out some value.